23A6, GFAJ-1, alien bacterium, earth, phosphate, arsenate, ions, Wow Seti, and there's the alien radio signal. And we're going to talk about lots of things in this video. GFAJ-1, alien UFO DNA, bacterium, earth, phosphate, arsenate, ions, Israel Science Foundation, tawfik, nella, Leon, benoziyo, Rev National Institutes of Health, bacteria strain, arsenate, phosphate DNA, biomolecules, life forms, aliens, physicochemical, 2 oxyanions, arsenate-esters, arsenate-diesters, unstable, aqueous media, substrate, phosphate-utilizing enzymes, arsenate-enzymology, proteins, biochemistry, machanistic probe, catalyzed reactions, breaking bonds, phosphoester bonds, keyword research, PDF file results, and alien DNA. Line 23, Wow Seti data. So I googled GFAJ-1. Quote and diagrams are from Wiki. GFAJ-1 is known to be an alien bacterium found on Earth. See lines 23's other videos about its findings and where it's located all over the world. So this is what it looks like. Comparison of phosphate P and arsenate AS ions. Okay. March 31st, 2014, quote, PDF from a blog. Arsenate replacing phosphate, alternative life chemistries and ion promiscuity, from tawfik and Biola. Department of Biological Chemistry, Weizmann Institute of Science, from Rovoit, Israel. And we have a Department of Chemistry from the University of Toledo, Ohio, USA. And this was published in January 7, 2011. That's the scientist's email address. DST is thankful to Michael, Elias, and Aaron Bar-Even for inspirational discussions, and to Israel Science Foundation and the Nella and Leon Benoziyo Professorship for financial support. REV is supported by a grant from the National Institutes of Health. Okay, so this is the hypoxanthine ribose, and then it's got all these other little letters and numbers here. A newly identified bacterial strain that can grow in the presence of arsenate and possibly in the absence of phosphate has raised much interest, but also fueled an active debate. Can arsenate substitute for phosphate in some or possibly in most of the absolutely essential phosphate-based biomolecules, including DNA? If so, then the possibility of alternative arsenic-based life forms must be considered. The physicochemical similarity of these two oxyanions speaks in favor of this idea. However, arsenate-esters and arsenate-diesters in particular are extremely unstable in aqueous media. Here we explore the potential of arsenate to be used as substrate by phosphate-utilizing enzymes. We review the existing literature on arsenate-enzymology that intriguingly dates back to the 1930s. So it's interesting that back in the 1930s they were talking about alien DNA. That's no surprise. They've obviously time traveled and been back and forth on Earth, probably at different time periods. And we won't find that out until we look at all the evidence. So we address the issue of how and to what degree proteins can distinguish between arsenate and phosphate and what is known in general about oxyanion specificity. We also discuss how phosphate-arsenate promiscuity may affect evolutionary transitions between phosphate and arsenate based biochemistry. Finally, we highlight potential applications of arsenate as a structural and mechanistic probe of enzymes whose catalyzed reactions involve the making or breaking of phosphoester bonds. That's from pubs.acs.org, and the keyword arsenic is going to continue in line 23A6. Okay, thank you for watching.